Okay, we are recording. Okay, so let me go to the slides where we left last time. I'm going to give some lecture at the beginning, short lecture, and then we are going to continue with more exercises. So we have seen all this. Okay, so look, sometimes we have different requirements. We need to do subnetting, but we would like to have different size of the subnet. Up to now, when we are doing subnetting, all the subnet have the same size. This is called FLSM, which is fixed length subnet mask, which means that all the subnets have the same amount of IP addresses inside. Now, let's say that we have a company with this requirement. Here we need 35 valid IP address. Here we need 30 valid IP address. Here 10, here 40, here 23. So a way to do it is to put in each subnetwork 64 IP addresses in total. But we will host a lot of IP addresses. For example, the people that are in the executive management department don't need 64 IP addresses in total, because they just need 10 valid IP addresses. So if we could just give them 16 IP addresses in total, it will be much better. So the idea of this is to try to do subnet with different size, which is called VLSM, variable subnet mask, variable subnet length mask. So let's say that you have a company with this network. So here we have a local area network, and they need 30 valid IP addresses. Here we have human resources, they need 23 valid IP addresses. Here we have the people of sale, they need 40 valid IP addresses. Here we have the execution management, they need 10 IP addresses, and here we have the technical support with 35 valid IP addresses. And we also have point-to-point network to connect those two routers. So here we have an additional network. Here we have an additional network, which is a point-to-point network, which will connect the main router to this router that give connectivity to the people of human resources. Here we have another point-to-point network, and here we have a fourth point-to-point network. So the number of networks that we have is 1, 2, 3, 4, 5, 6 with this point-to-point network, 7 with this point-to-point network, 8 with this point-to-point network, and 9 with this point-to-point network. So let's say that the initial network that we have is this one, 172.16.0.0/22. And we need to divide this network, this original network, in subnets. So to satisfy the requirement of this company, how many subnets should I create? What will be the minimum number of subnets that I should create to satisfy the requirement of this company? We saw that we have 9 subnets, no? I count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 subnets. So what will be the minimum number of subnets that we need to create? Can we create exactly 9? We have to create 16. Out of the 16, we will be using 9, and we will have 7 spare subnets. So if the company grow in the future, there will be no problem, because we will have some spare network. We will have 7 spare network. We cannot create 9. What we can create is 1 or 2 or 4 or 8 or 16 or 32 subnets. So if I have a requirement of 9, I have to create 16. To create 16 subnetwork, how many bits I need to borrow? on the host part and change this bit to subnet. To create 60 subnet, how many bits I need to borrow? If I borrow 5, 2 to the power of 5 is 32. So it's not 5. I need to create 16 subnetwork. So it will be what? 4, yeah, obviously. 2 to the power of 4 is 16. I need to borrow 4 bits. So look at, this is the original subnetwork. This is the original network. It's a /22. So look, this is 172.16.0.0. So it's a /22. So up to here it's 8 bits. Up to here it's 16, 17, 18, 19, 20, 21, 22. So here we have all the bits that belong to the network part. And here, the remaining bit, which is 10 bits, originally they belong to the host part. So all these 10 bits in the original network here, these 10 bits belong to the host part. Since we are going to borrow 4 bits, so we are going to borrow this bit, this bit, this bit, this bit, and convert this 4 bits into subnet. Look at what we will have. We will have 4 bits for subnet. If we have 4 bits for subnet, we can create 16 subnets. So this will be subnet 0, subnet 1, subnet 2, subnet 3, 4, 5, 6, blah, 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 blah. Here we have subnet 14 and subnet 15. The subnet go from 0 up to 15. Subnet 0, subnet 1, up to subnet 15. Of course, 1111 is 15, no? 1110 is 14. It's why here we talk about subnet 14. And 000 is subnet 0. 0001 is subnet 1. Okay? So the initial mask was a /22. Since I borrow 4 bits, all the subnet will be what? What will be the subnet of all the subnet mask of all the subnet? So 22 plus 4 that I borrow become a 26. So all the subnet are going to be /26. Okay, if I compute the magic number of /26, how do I compute the magic number? So let me show you again how we will compute the magic number. So let me open Paint so I can write. So it's a /26. /26 in binary will be what? 255, 255, 255, 192, isn't it? This is /26. So if I want the magic number, MN for magic number, I will parse the subnet mask in search of the last byte that is not 0. So the last byte that is not 0 is this one. And the magic number is always 256 minus this number. 256 minus 192 give us 64. So the magic number is 64 and it is in the 4th byte, which means that from one subnet to the next subnet, I will go by a step of 64 in the 4th byte. So if you look, this is the first subnet. It's a /26 and it's end with 0. So we already know that the magic number is 64 and it is in the 4th byte. So 0 plus 64 is 64. That will be the second subnet, or subnet number 1. 64 plus 64 will be 128. That will be the third subnet, or subnet number 2, as you can see here. 128 plus 64 will be 192. That will be the fourth subnet, or subnet number 3. 124, 192, sorry, 192 plus 64 will be what? 256. Can I write 256? No. So there is a carry of 1, so this 0 becomes a 1, and I put 0 here. So this will be 1, 2, 3, 4, the fifth subnet, or subnet number 4. And I keep going. 0 plus 64 will be 64. 64 plus 64 will be 128. So then we have 192. Then we have 2 0. Then 264. Then 2 128. Then 2 192. Then we have 3 0. All of them are not shown here, no? Then we have 364. Then we have 3 128, which is shown here. And then we have 3 192. This will be the last subnet. So we have all these subnets. So once we have defined all the subnets, we need to do a mapping. So we need a total of 9 subnets, if you remember. So we can say, for example, this subnet, the first subnet, I put it here. This subnet, for example, I put it here. We can do that like that. We need to do a mapping between the subnet that we have and the LAN that we have and the point-to-point connection that we have, the different network that we have here. There is something also that we need to verify. How many IP addresses have each subnet? So how many bits is left for the host part? 6 bits, no? Look at the host part will be this one. 6 bits. 2 to the power of 6 is 64. We have 64 IP addresses in each subnetwork. Is 64 IP address enough for the engineering department? Yes. They need 30. I could have given them 32 and they will be happy. Is 64 is enough for human resources? Yes. They need 23. So I could have given them a network of 32 IP addresses in total. Is 64 enough for the people of Cell? Yes. They need 40 valid IP address. I'm giving them 64 IP address in total, which is 62 valid IP addresses, no? Is it will be enough for the executive manager? Yes. It's much larger than what they need. Is it enough for here also? Now, for the point-to-point network, we need 2 valid IP address. One that we will put in this interface of the router, and another one that we will put in this interface of the router. If I need 2 valid IP address is how many IP address in total I should have in the network? The list that it will that will work will be what? I need 4. If I have 4 IP address in total, remember that we lose the first IP address and the last IP address. So we'll have 2 valid IP addresses. So in a point-to-point network like this one, we need 2 valid IP addresses. So with 4 IP addresses in total, I can satisfy the requirement here. Of course, I have 64. I'm hosting a lot of IP addresses because I oversized the size of the network here. The number of IP addresses that I will have in this network is too big. Since it's too big, I'm hosting IP addresses, okay? But since we are using subnet of the same size, we don't have the choice. To satisfy, for example, the requirement of Cell, we do need to create subnetwork with 64 IP addresses. And those subnetwork will be too large, very large for this, no? So I'm hosting IP addresses, let's say. Okay, so this is the same exercise with the 16 network. We have 16 network in total. And as you can see, this is network number 0. We assign it to this LAN. Network number 1, we assign it to this LAN, LAN 2. Then we assign network number 2 to this LAN. Then we assign this network to this LAN, to LAN 5. Then we assign this network, which is subnetwork number 4, we assign it to LAN 3, as you can see. Then this one is in spare, we don't use it. This one also is in spare, we don't use it. This one is also in spare, we don't use it. Then we have a point-to-point network between this router and this router. And we are using this subnet number 11. Then we have a point-to-point connection between these two routers. We are using subnet number 10. Then we map, for example, subnet number 9, as you can see here, in this point-to-point network. And finally, we map subnet number 8, which is 172.16.2.0, with this point-to-point network. This subnet is in spare. This one is in spare. This one is in spare. This one is in spare. In total, as I was telling you, we need 9 subnetwork. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we will have 7 in spare. 1, 2, 3, 4, 5, 6, 7 in spare. So the company can grow and we still have some flexibility to accommodate new department in the company. Let's do a second exercise. Let's do that the topology of a company is this one. So as you can see, we have a LAN here in building A, and they require 25 IP addresses, valid IP addresses. We have another LAN here in building B with this requirement in valid IP addresses. Another LAN here in building C, and another LAN here in building D with this requirement in building C and this requirement in building D. And we have point-to-point connection between router 1 and router 2. Another point-to-point connection between router 2 and router 3. And another point-to-point connection between router 3 and router 4. So if I ask you, you are asking, for example, to propose address plan for this company. How many subnetwork you need to create from the original network to satisfy this requirement? How many subnetwork? So we just count the number of subnetwork. How many subnetwork we have in this diagram? 7, correct. So 1, 2, 3, 4, 5, 6, 7 network, 7 subnet I need to create. If I need to create 7 subnet, can I create exactly 7? Can I create exactly 7? No. What can we create? That is bigger than 7 and is a power of 2. 8. We can create 8. So we will be using 7 out of the 8, and 1 will be a spare network. Okay? So we need to create 8 subnetwork. If we need to create 8 subnetwork, how many bits we need to borrow from the host part and change them to subnet bits to create 8 subnetwork? We need to borrow 3 bits. If I borrow 1 bit, I can create 2 subnetwork. If I borrow 2 bits, I can create 4 subnetwork. If I borrow 3 bits, I can create 8 subnetwork. Okay? So we need to borrow 3 bits. So this is the original network. The original network is a /24. If I'm going to borrow 3 bits, what will be the subnet mask of all the subnetwork. So 24 plus 3 is 27. Okay? Initially, I have 24 bits. Look at here. We have the information of the original network. The original network is this one, which is 192, 168, 20. So all this is the network portion. And initially, we have the host portion, which is 8 bits, because it's a /24 initially. Now, if of the 8-bit of the host portion, I borrow 3 bits, so the subnet mask will have 1 up to here. So it will be 8 plus 8 plus 8 plus 3 bits. And 8 plus 8 plus 8 plus 3 is 27. So I went from a /24 to a /27. So all the subnets, as we can see here, will be /27. So let's compute the magic number. So a /27 is 255.255.255.224. So to compute the magic number, I need here the last byte that is not 0. The last byte that is not 0 is this byte, 224. So the magic number is always 256 minus the value of this last byte that is not 0. So 256 minus 224 give me 32. Which means that since the magic number is 32 and is in the 4th byte, in the 4th byte we will have to go by step of 32. So look at this will be the first subnetwork. And in the 4th byte I'm going to go by step of 32. So 0 plus 32 will be 32. 32 plus 32 will be 64. 64 plus 32 will be 96. 96 plus 32 will be 128. 128 plus 32 will be 160. 160 plus 32 will be 192. And 192 plus 32 will be 224. If you add 224 plus 32, you will arrive to 256. Okay? But this does not belong to the original network. So those will be the subnets. Okay, we go by step of 32 in the 4th byte. So this will be subnet number 0. Why we call it subnet number 0? Because if we look at the S bits, we have SSS, 3 S bits. This value is 0. This is subnet number 1. We call it subnet number 1 because SSS is 001. So this is subnet number 1. This is subnet number 2, 3, 4, 5, 6, and 7. I will also say the first subnet, second subnet, up to the 8th subnet. Because we have 8 subnets, no? So those are the subnets. We have a total of 8 and we need 7. So now we need to do a mapping. Take one of these 7 for building A. One of the 8, sorry. We have 8 subnetwork. So take one of these 8 for building A. Another for building B. Another for building C. Another for building D. So for example, we could take this one and put it in building A. This one, the second one, and put it in building B. The third one, we could put it, for example, in building C. The 4th one, we could put it in building D. Then we need subnet for the point-to-point connection. So we need 3 subnets, one here, one here, one here. So we could use this one, for example, here, between router 1 and router 2. This one, which is the 192.168.20.160/27, we could put it between router 2 and router 3. And this one, the 192.168.20.192/27, we could put it between router 3 and router 4. And there is a spare network a network that is available, that is not used. So the company can grow because we still have a spare network. Okay? So this is called a mapping. You take a subnet, and you assign it to part of your network, no? So let's verify that each subnet is big enough to accommodate the requirement of all the building. So in the host part, I have 1, 2, 3, 4, 5 bits. If I have 5 bits, how many IP addresses I will have in each subnet? How many IP addresses we will have in each subnet? 2 to the power of 5, and 2 to the power of 5 is 32. So is 32 enough for the building A? Yes. They are requiring 25 valid IP addresses, and I'm going to give them 30. Okay, because in a network that have 32 IP addresses, 30 are valid. Remember, we lose the first IP address and we lose the last IP address. Is 32 will be enough for building B? Yes. They need 20 valid, and I'm going to give them 30. Is 32 is enough for building C? Yes. They need 15 valid, and I'm going to give them 30 valid. And is 32 IP addresses in total enough for building D? Yes. They need 28 valid IP addresses, and I'm giving them 30 valid IP addresses. So there will be the subnetwork will be big enough to accommodate the requirement of each LAN, each local area network. Okay? So, yes?
So does it matter which IP address we map to a LAN?
No, it doesn't matter which subnet you map to, for example, a LAN or to a point-to-point connection. As long as the subnet is big enough to accommodate the requirement of the LAN or the requirement of the point-to-point connection. A point-to-point connection just needs 2 valid IP addresses. If I need 2 valid IP addresses, a network with 4 IP addresses in total is big enough. But we are going to put network here with 32 IP addresses. So I will have 30 valid IP addresses, and I just need 2. A total of each subnetwork here will have 32 IP addresses, no? 30 of them will be valid, and we just need 2. Okay, so what happened is that we are hosting a lot of IP addresses when we do subnet of the same size. So look at, let's say that we have 256 IP addresses, and we create a subnetwork. All the subnetwork are going to have 32 IP addresses. So this is called fixed length subnet mask, which means that all the subnet that we create have the same size, 32 IP addresses. So this was the case historically at one point. Then we saw that it was not good because we were hosting a lot of IP addresses. So we moved from fixed length subnet mask to variable length subnet mask. So in variable length subnet mask, we create subnet of different size. So if you look here, we create a subnet of 32 IP addresses in total. This one also have 32, this one have 32, 32, 32, 32, 32. But here, we create a subnetwork of 4 IP addresses. So as you can see, the subnetwork that we are creating have not the same size. So I'm free now to create subnet of different size. The important thing that each subnet must have a number of IP address which is a power of 2. So 4 is a power of 2. 32 is a power of 2. You cannot create a subnet with 7 IP addresses or with 10 IP addresses. We can create 16, or you can create 8, or you can create 32. It has to be a power of 2. So a way to see variable length subnet mask is that you do a first division of the IP addresses, and then you take a subnet, the one that is here in pink, and you divide it one more time. So you do a second division. So it allows you to have different sizes. For example, I could take this one and divide this one in 2 subnets of 16 IP addresses. I could take this one and divide this one in 4 subnets of 8 IP addresses. You see? So you can divide a little more if you want. But always remember, we have to work with power of 2. So let's take our exercise, our previous exercise, and let's do something better, where we will not spare that many IP addresses. So look, here we have a LAN, another LAN, another LAN, another LAN. So we have 4 LAN. Here we have a point-to-point connection, a point-to-point connection, and a point-to-point connection. We need a total of 7 subnets. So what I'm going to do this time is that initially I'm going to create 8 subnets. So the 8 subnets are those ones that we saw previously. So this one, for example, I assign it to building A. This one, I assign it to building B. This one, I assign it to building C. And this one, I assign it to building D, as we did previously. But previously, we're taking this big network to put it here, between router 1 and router 2. This big network to put it here, between router 2 and router 3. And this big network to put it here, between router 3 and router 4. So we were sparing a lot of IP addresses. And the only available network that is left, if I do that, is the last subnet. So this time what we are going to do is we are going to take, for example, the last subnet, and we are going to further divide the last subnet. So we are going to do that. We are going to take the last subnet and divide it even more. So here we take this /27 subnet, and we are going to divide it in 8 subnetwork. So here I have 32 IP addresses. If I divide 32 IP addresses in a subnetwork, how many IP addresses I will have in each subnetwork? 4. Which means that the magic number will be 4 in the 4 bytes. So look at what will happen. The first subnet will start in 224. And we will go by step of 4 to find all the 8 subnets that we will create from this subnet. So 224 plus 4 will be 228. 228 plus 4 will be 232. 232 plus 4 will be 236, up to 252. And those will be the subnet. So what will happen? That initially, when we did our subnet, we borrowed 3 bits. Now, if we want in the last subnet to create 8 subnets, we need to borrow another 3 bits. So in total, we will be borrowing 6 bits. So if the original network was a /24, 24 plus 6 is 30. All these subnets, all these 8 subnets, will be /30, which is 255.255.255.252. And instead of doing what I did previously, use this big network to put here, now I'm going to use this small network and put it here. This small network and put it here, and this small network and put it here. So I'm not sparing that much IP addresses. After that, because I use subnet of different size, look at what we have in spare. We have these 3 network in spare and this 5 network in spare. Previously, we just have, if I go back, previously, we just have 1 subnetwork in spare. Now we have much more subnetwork in spare that we can use for future use. We can keep there for future use if the company grows. So as you can see, we have 3 subnetwork of size 32 IP addresses that are left, and 5 subnetwork of size 4 IP addresses that are left. So if the company grows in size, we have much more flexibility this time because we use variable length subnet mask, which means that we are creating subnet of different sizes. That will be the configuration of R2 in a Cisco router. We will see that very soon. Let me skip it. So that was our exercise. We create initially 8 subnetwork. So the magic number was 32. We went by step of 32, no? We create a subnetwork. Then we took the last subnetwork and subdivide the last subnetwork in another 8 subnetworks. So we initially have 32 IP addresses here. So if we are going to create 8 subnetwork, each subnetwork will have 4 IP addresses. And this is the range of valid IP addresses. For example, in the first subnetwork here, we have only 2 valid IP addresses, but this is exactly what I need in a point-to-point network. I need just 2 valid IP addresses, and those valid IP addresses will be .225 and .226. .227 will be what? For this subnetwork. It will be what? The broadcast address. And .224 will be what? This one. The network address. Remember that we lose 2 IP addresses in a subnet. The first IP address is the network address, and the last IP address that we lose also is the broadcast address. So we will lose the first IP address, which is .224, and we will also lose .227. But valid will be .225 and .226 in this first subnetwork of 4 IP addresses. No? And the same thing will repeat in all subnetworks. For example, in the second subnetwork of 4 IP addresses, .228 will be the network address, and .231 will be the broadcast address. So valid are .229 and .230. Okay, let's do another exercise. Let's say that my initial network is 192.168.1041/24. How many IP addresses I have here? 256. If I want to do 4 subnetwork of the same size, how many IP addresses will have each subnetwork? 256 divided by 4, which is 64. So this will be the first subnetwork with a 0 at the end, the second subnetwork, the third subnetwork, and the fourth subnetwork. Now we can, for example, take the fourth subnetwork, which has 64 IP addresses, and divide it in 2 subnets. And each subnet will have 32 IP addresses. If I do that, I have to go by step of 32 here in the 4th byte. So 192 plus 32 is 224. So I will have created 5 subnetworks. This one has 64 IP addresses. This one has 64 IP addresses. This one has 64. This one has 32. And this one has 32. So you see, with variable subnet mask, we can create, the number of subnetwork doesn't have to be a power of 2. but all the subnetwork must have a size that is a power of 2. Okay, so what we can do, we do a first division, then we take a subnet and divide this subnet. And we can go deeper. We can take a subnet and divide it even more. Then we can go deeper. We take a subnet and divide it even more if we want. Okay, so you can do that. It's recursive. You can recursively go inside and make more division. Let's do an exercise. Let's say that this is my original network, 172.16.0.0/23. How many IP addresses I have in this network? In total. So how many bits are dedicated to the host part? 32 minus 23. And 32 minus 23 is 9. So 2 to the power of 9 is 512. So the total number of IP address in the original network is 512 IP addresses. Okay? Let's say that I have several departments in my company. I have 1, 2, 3, 4, 5 departments. For the first department, they need 200 host IP addresses. Can I give them exactly 200? No, because it has to be a power of 2. So what is the power of 2 that is bigger than 200 and is the smaller one? 256. So to this network, there is a requirement of 200 IP addresses that are valid. I will give them a total of 256 IP addresses. Then the second department also have a LAN, and they need a total of 100 host IP addresses. Can I give them exactly 100? No, I will give them 128. Then this department needs 50. Can I give them exactly 50? No, I will give them 64. This department needs 25. Can I give them exactly 25? No, I will give them 32. This department needs 10. Can I give them exactly 10? No, I will give them 16. And we have also 4 point-to-point network in the company. So what will be the minimum size of IP addresses for each point-to-point network? 4. When you have a point-to-point network, you need 4 IP addresses. Remember, you are going to lose 2 IP addresses, the first one and the last one. So valid will be 2. This is exactly what you need in a point-to-point network, because in a point-to-point network, you connect 2 devices. If you connect 2 devices, you need 2 IP addresses. So if we have 4 point-to-point network, and each network will have 4 IP addresses, we need another 16 IP addresses. So in total, let's see, we need 256 plus 128 plus 64 plus 32 plus 16 plus 16 for the point-to-point addresses. For the point-to-point network, I should say. When you add up all these numbers, it gives you 512. This is exactly what I have. So I can solve this problem with variable length subnet mask. I will not able to solve this problem with fixed length subnet mask, because I'm wasting too much IP addresses when I use fixed length subnet mask. Okay? So look, I started with this network, 172.16.0.0/23. 172.16.0.0. I need 256 IP addresses in the first network. So it will be a 4/24. Now, I still have 256 IP addresses left. In these 256 IP addresses, I need to put this first 128. So I will put them in 172.16.1.0. This network will go up to 172.16.1.127 because it has 128 IP addresses. So the next network will start at 128. And in this 128, I'm going to put 64. 128 plus 64 is 192. So this will go from 128 to 191. Then we have a network of 32 IP addresses. 192 plus 32 will give me 224. So this network, the fourth network, will go from 192 to 223. And we keep going to accommodate the need of each subnetwork. Okay, I hope this is clear. Now we are going to do more exercises to get familiar with subnetting with different size. So let me go back to the last exercise that we were doing. If I remember correctly, it was in this exercise, which is exercise 2, and we did this last exercise. Okay? Let's do exercise 7. So giving the network 180.19.0.0/16, you are asked to divide this network into 4 subnets of the same size. Complete the following table. So you need to give all the information of the 4 subnets. So how can we do that? So first of all, if I'm going to do 4 subnets, how many bits I need to borrow on the host part to create 4 subnets? 2 bits, you're right. With 2 bits that we borrow, we create 4 subnets. So the initial net mask is a /16. /16. It will go, if I borrow 2 bits, it will go to what? To a / what? 18. What is a /18 in dotted decimal notation? 255. What? 255. Here I will put what? 192, 0. Isn't it? That will be the subnet mask. This is the net mask, and this will be the subnet mask after borrowing 2 bits. Okay, I want to compute the magic number. So what will be the magic number? So I parse the subnet mask in search of the last byte that is not 0. Is this the last byte that is not 0? No. Is this the last byte that is not 0? No. Is this the last byte that is not 0? Yes, because we start here, we have a 0. So the last byte that is not 0 is 192. So what will be the magic number? It is always 256 minus the last byte that is not 0. 256 minus 192 is what? 64. So the magic number is 64. And it is in which byte? In the first byte, in the second byte, in the third byte, or in the fourth byte? It is in the third byte. Note here, we find that the last byte that is not 0 is the third byte. So it is in the third byte. So what can I say? When I will go by step of 64 in the third byte. So I come back here. Let's put our original network. 19, 0, 0. So we went to a /18. Okay, because we borrowed 2 bits. So what will be my second subnet? What should I put here? Let's just copy it. Now I'm going to take this, copy it, and we modify it after. What modification should I do here to get the second subnet? So the magic number is 64 in the third byte. It means that we must go by step of 64 in the third byte. So 0 plus 64 is 64. 64 plus 64 is 128. And 128 plus 64 is 192. We go by step of 64 in the third byte. With this, magically, without putting any binary number, we get all the subnet. We have 4 subnets. So let's fill this. The first valid IP address. The first valid IP address is the IP address that is after this one. So what will be the IP address after this one? Yeah, 180.19.01. Correct. Okay. For the second subnetwork, what will be the first valid IP address? So one IP address after this one will be what? Exactly. 180.19.64.1. One IP address after this one. Let me just copy it and modify it. Will be .1 here. And one IP address after this one will just be .1 here. Okay. If I want the broadcast address, the broadcast address of this network, of the first network, will be one IP address after the starting of the next network. So the next network, which is the second network, starting 180.19.64.0. So the previous network, which is the first network, must end where? It must end where? In 180.19.192. Sorry, it must start where? What is one IP address before this one? Exactly, it will be 63.255. One IP address before this one, so the second network starts here. So the first network have 2 and one IP address before this one. And one IP address before 180.19.64.0 is 180.19.63.255. So what will be the last IP address of this network, of the second network? It will be one IP address before where the third network starts. The third network start is 180.19.128.0. So the previous network, which is the second network, will end where? Exactly, 127.255. Okay, this is one IP address before this one. Remember, subnetworks are one after the other one. They are back to back. So if you have the IP address of the last IP address of the network, you know where next network start. So if this the last IP address of network 1, the next network will start one IP address after this one. One IP address after this one will be this one. Okay? Okay, if I want the broadcast address of the third network, it will be one IP address before this one. What is one IP address before 180.19.192.0? Exactly, it will be 180.19.191.255. Correct. And the last subnet, what will be the broadcast address? Exactly, at the end 255.255. So 180.19.255.255. Now, the last valid IP address is one IP address before this one. What is one IP address before this one? What should I put there? In the last byte, 254. Correct. So the last valid IP address here is one IP address before the broadcast address. This will be 254. Okay, I take this one, and it will be 254 also here. And I take this one IP address before 255 will be 255.254. So this is the information of all the subnets. You see? So online, you will find subnet calculator, and they will give you this information. We can Google one. Let's Google one and verify those results. But those results are correct, no? I need to run Chrome. Okay, so subnet calculator. I don't know. I've never used this one. Let's try it. Oh, this is to download. We don't want to download. We want one that is online. Let's see this one. Okay, this one is online. So let's see if we can use it. So initially, the network that we have is 180.90.0.0/18. And no, /16, sorry. And we want to do a /18. Let me calculate here. And look at. It's telling me there are 4 subnetworks. This is the information of the first subnetwork. So as you can see, it's exactly what we found, no? We tried to put both of them. So look at. It says the first subnetwork start in 180.90.0.0. It's the network address. This is what we have here, the network address. This is the range of valid IP address. They go from 180.19.0.1, 180.19.0.1, up to 180.19.63.254. And the broadcast address is 190.19.63.255, as you can see it here. Then we have the second subnetwork, the third subnetwork, and the fourth subnetwork. So that's correct. Okay, we could verify that we didn't make any mistake, no? With this online subnet calculator. Let's do another exercise. So in this exercise, which is exercise 8. Let me put it in the same page. Given the network, so the initial network is 201.16.15.32/28. You are asked to divide it in 4 subnets of the same size. So, how many IP addresses we have there in the original network? It's a 4/28. So how many bits are dedicated to the host part? 4 bits, correct. 32 minus 28 is 4. 2 to the power of 4 is 16. So in the original network, I have 16 IP addresses. If I divide an original network that has 16 IP addresses in 4 subnetworks of the same size, how many IP addresses will have each subnetwork? 4. Okay? So the magic number must be 4. Let's show that the magic number is 4. So let me bring paint again. Okay, so originally the mask is 4/28. This is the original mask of the network. To do 4 subnets, I need to borrow 2 bits. So the subnet mask, 28 plus 2, will be 30. 30 in dotted decimal notation is 255, 255, 255, 252. What will be the magic number? Exactly. 256 minus the last byte that is not 0, which is 252. Let's give me 4. And the magic number, as you can see, is in the 4th byte. It's not in the 3rd byte. In the previous result, in the previous exercise, it was in the 3rd byte. Here it is in the 4th byte. So I have to go by step of 4 in the 4 bytes. So let's put the information of the subnet. Let me copy that here. So remember, the subnet mask will be 30. Let me just copy this information 4 times. Here, here, here. And the magic number is 4 in the 4 bytes. 32 plus 4 will be what? 36. 36 plus 4 will be what? 40. And 40 plus 4 will be what? 44. Those are the subnets. So let's see. What are the IP addresses that I have in this subnet? I have 4 IP addresses. .32, .33, .34, and .35. So of course, if this one starts in .36, this one has to end in .35. So the broadcast address will be 201.16.15.35, which is one IP address before where the next subnet starts. Okay? So what will be, for example, the broadcast address of the second subnet? So if the third subnet starts in 40, this one has to end in 39. So 201, 16, 15, 39. Okay, what is the broadcast address of the third network? So if the fourth network starts in 44, this one has to end in 43. So 201, 16, 15, 43. What will be the last broadcast address? So we can compute what will be the next subnet. 44 plus 4 will be 48. So the next subnet, if we did have one, will start in 48. We don't have this next subnet. But hypothetically, if we have one, it will starting in 48. So this one have to end in what? 7. Okay? Okay, if I do the last valid IP address, what is one IP address before this one? It will be 34. What will be the IP address before this one? It will be 38. What will be the IP address before 43? It will be 42. And the IP address before 47 will be 46. Now, the first valid IP address is the IP address after the network address. So this is the network address. After 32, I have 33. After 36, I have 37. After 40, 41. And after 44, 45. So look, how many valid IP addresses I have? Only 2, 33 and 34, because we have 4 IP addresses. We lose the first one, we lose the last one. Valid, we will have 2. So when the network has 4 IP addresses, we just have 2 valid IP addresses. So the range of valid IP addresses is only 2. So if I take my calculator again, let's go back to the calculator that we previously found. We close what we don't need. We don't need that anymore. Okay, so there. Let's put the original network here. So the original network is what? 201.16.15.32/28. And I want to create subnet that are /30. Okay, /30, which is 255, 255, 255, 252. Let me click on calculate. What did I did? /28, 201, 16, 15, 32. Yeah, what it doesn't like here. I don't know what it doesn't like, but I can go to another calculator to see if it's do it well, because this one doesn't want to do it well. Protest something. Please provide a valid IP address. Yeah, this is a valid IP address. 28. Yeah, it is. Okay, let's go to another. Subnet IP calculator. Let's try this one to see. So this one, look at how it's worked. It's a little better. I like more this one. 201.16.15.32 is the original. And the original mask is a /28. And we want to move to a /30. So let's do calculate. Move to, I just put 30. Yeah, I have to put just 30. Oh yeah, here we don't put the /. Look, so this is the original network. And this is the subnet. So we have information of the first subnet, information of the second subnet, information of the third subnet, and information of the fourth subnet. So look, if you look at this is the information of the first subnet. Look that we have exactly the same thing. So it say the first subnet is 201.16.15.32/30 as we have here. The broadcast address is 201.16.15.35 as we have here. The first valid IP address is 201.16.15.33 as we have here. The last valid IP addresses is 201.16.15.34. The number of valid IP addresses is 2. Look, it gives you the information here in binary. This is what I like also. Now, if we take the second subnetwork is 201.16.15.36, 201.16.15.36/30 as we have, and the valid IP addresses go from 37 to 38, 37 to 38, and the broadcast address is 39, correct. Now, if we go to the third network, which is this one, 40/30, 40/30. The valid IP addresses go from 41 to 42, 41 to 42. The broadcast address is 43, 43, as you can see now. So I like merge this calculator. We can keep this calculator to do our verification. Okay, let's see this one. Given the network, they give you a network here. And they ask you, you are asked to divide this network into 8 subnets of the same size. So, help me with that. What will be the new net mask? Or the subnet mask? So the original one is a /26. The original one is a /26. If it is a /26, the original network have how many IP addresses? So 32 minus 26 give me what? 6. 2 to the power of 6 give me what? 64. So the original network has 64 IP addresses. If I'm going to create a subnetwork, what will be the size of each subnetwork? 64 divided by 8, give me what? 16. So each subnetwork must have 16 IP addresses. So by seeing this 16, I know that the magic number should be 16. But let's do it. If I'm going to do 8 subnetwork, how many bits I need to borrow? 3 bits. So if I borrow 3 bits, I will go from a /26 to what? To a /29, correct. A /29 in the dotted decimal notation will be what? So 255, 255, 255, up to here. How many one I have? 24. How many are missing? 5. So if 5 are missing, the last byte must be 248. What will be the magic number? It's always 256 minus the last byte that is not 0. Who is the last byte that is not 0? This byte, isn't it? So it will be 256 minus 248. 256 minus 248 give me what? 16. So the magic number is 16 and it is in the 4th byte, which means that when I create my subnet, let me start with this. and copy it here. And we know that we go to a 29. Let me copy this several times. We know that in the 4-byte, we have to go by step of 16. So 128 plus 16 will be what? 144, isn't it? 144 plus 16 will be what? 160. 160 plus 16 will be what? 176. 176 plus 16 will be what? 192. 192 plus 16 will be what? 08, isn't it? 208 plus 16 will be what? 224. 224 plus 16 will be what? 240. Those are the network. When I have the magic number, it's easy to find all the network. If you have all the network, it's easy to complete the table. So look, if the second subnetwork starts here, this subnetwork must end where? One IP address before 144 is 143, isn't it? Okay, if the third subnetwork starts in 160, the second subnetwork must end where? In 159. In the fourth subnetwork start in 176, the third network must end in 175. If the fifth subnetwork start in 192, this fourth subnetwork must end is 191. If the sixth subnetwork start in 208, the fifth subnetwork should end in 207. If the seventh subnetwork start in 224, the sixth subnetwork should end in 223. If the eighth subnetwork start in 240, the previous subnetwork should end in 239. Okay, how do I find this one? So look, 240 plus 16 will be what? 256. So which means that if I'm talking about the network that come, the subnet that come after this one, it will be which one? Let me write it here just to see. So 240 plus 16 will be 256. Can we keep 256? No. So we put 0 here, and we have a carry, so it will be 24. So if the hypothetical next subnetwork did exist, it will start in 24.0. So this one will end where? What is the IP address before 24.0? 23.255. You see? It's one IP address before the hypothetical next subnetwork that does not exist. So let me just copy all this column and just modify. So here, one IP address before 143 is 142. One IP address before 159 is 158. Here it will be 174, 190, 206, 222, 238, 254. Now, one IP address after all this. One IP address after 128 will be 129. One IP address after 144 will be 145. One IP address after 160 will be 161. One IP address after 176, 177, here it will be 193, 209, 225, and 241. Okay? You see how fast I can fill that? Now, let's take our calculator from the internet and verify all this. So we are going to say our original network is 201.50.23.128. It was a 26, and we want to go to a 29, a /29. Calculate. So look, let's count the number of subnets. 1 subnet, 2 subnet, 3 subnet, 4, 5, 6, 7, 8. By the way, it says here 8 subnets. Okay, let's just verify, for example, the third one. So this will be the first one, second one, third one is here. So let's verify the third one. The third one, let me put it here and put this guy here. So the third one is 221.50.23.160. Is this the third one? First, second, third?
I guess we use 16 to 8.
What did we do wrong?
16 to 8.
Where? We use 16 instead of 8. The size of the original network was 64, isn't it? Yeah, 26 is 64. 64 divided by 8 is 16. 64, oh my God. So, yeah, so plus 8 here will give 136, isn't it? 136 plus 8 will give us 144. Let me just do the first 3 So why you didn't tell me that on time? Why you let me go and do all the exercise to tell me that? Okay. So if I do the first valid, give me 129 here. 136 plus 1 will be 137 and 145. If I do the last valid, the broadcast address. The broadcast address before 136, we will have 221.50.23.135. Then one IP address before this one, let me just copy it and paste it here, will be 143. Let me do the next one here. So if I add 8, I will get 152, no? So one IP address before 152, 151. So the last valid IP address here, let me just copy it. It will be 420. So I wanted to check the third subnetwork. Let's see the third subnetwork. So first subnetwork, second, third subnetwork is here. So it starts in 144, as we have here. The range of valid IP address is from 145 to 150, 145 to 150, and the broadcast address is 151. Okay, and we have 6 valid IP addresses. So of course, from 145 to 150, we have 6 valid IP addresses, no? 145, 146, 147, 148, 149, and 150. Give us 6 valid IP addresses. Okay, it's very important. I told you that you contribute to the class. So can you imagine I make the mistake, nobody say nothing on time. So I keep going, and at the end, we realize, oh yeah, you did a mistake. We cannot arrive to the end when you tell me about the mistake. You have to tell me that before. Okay, let's do this exercise. Exercise 10. One page. Okay, so you have this as the original network, and you are asked to divide into 32 subnets of the same size. So the original net mask is /3022. /22. If I want to do 32 subnet, I need to borrow how many bits? 5 bits. So I will go from a /22, which is the network mask. 22 plus 5 will be 27. So the subnet will be /27. Let's put /27 in the decimal dotted notation. So it will be 255, 255, 255, and the last one will be what? 224, isn't it? I need 331 here. So the magic number will be what? 256 minus 224. And it's what? 32. So we will have to go by step of 32 in the 4th byte. Another way to see it, the original network have how many IP addresses? So 32 minus 22 is 10. So 2 to the power of 10, it have 1024 IP addresses in total, isn't it? If you are going to create 32 subnets, so let's divide 1024 by 32. This is 2 to the 10 divided by 2 to the 5. It's giving me 2 to the 5. So each subnet must have 32 IP addresses. So the magic number confirms that the size of each subnet is 32 IP addresses. So remember, I have to go by step of 32. I take this, I copy it. Copy it, copy it, oh, I should update this. So we borrow 5 bits, no? So we want to 27, no? Yeah. So 27, 27, 27. Okay. We go by step of 32. So 0 plus 32 is 32 for the second subnetwork. Third subnetwork, 32 plus 32 will be 64. Fourth subnetwork, 64 plus 32 will be what? 96. Look, they don't ask me the 5th, 6th. They just ask me subnetwork 29. How do I get that? What should I put here? So if you look, this 32 is what? Is second subnetwork times 32. This 64 is what? Third subnetwork minus 1 times 32. This fourth, it will be what? This 96. Fourth subnetwork minus 1 times 32. So the 29th subnetwork will be what? 29 minus 1 times 32. Remember, we go by step of 32. So what should I put here? I take my calculator and I do it. So let's put the scientific calculator. 39 minus 1 times 32. Okay, what happened here? We get 896. What should I do? Can I put 896 here? Let me put 896. Can I put 896 here? No. So 896 is what? What is 896? It's exactly as the hours. When you work with the hours, so 800 896 is what? Is 512 plus, let me do minus 512. Oh, it's more than 512. Minus 256. So it's 512 plus 256. It's 768. Plus 128, which is 3 times 256 plus 128. So instead of putting here 896, I will put what? According to the computation that we just did. I will put 128. And instead of putting 24 here, I will put what? 27, very good. So the next one here will be 27, since we go by step of 32. 128 plus 32 will be what? 144. Then 144 plus 32 will be what? 192 plus 32 will be 190. Is it correct? 196? Huh? 76? Okay. Plus 32 will be, yeah, it's wrong. You're right. So it will be 160, no? Yeah, 160. So 160 plus 32 will be 192, and 192 plus 32 will be 224. So those are. So we can compute, for example, if I want to do this one, it's easy. 14, 22, 27, 161, isn't it? Now, the broadcast address will be 1 before this one. 1 before this one will be what? 191 here. The last valid IP address will be 1 before 191. It will be 190. Okay? So if I want to verify it, for example, I want to verify this network. Let's do it here. So let's put that the original network was 14.22.24.0/22, and we want to a /27. Calculate. Okay, look at a lot of subnetwork. This is the last subnetwork. I want to verify this one. So this is the one that is next to the last, and this is the one that I want to verify. So look at 14.22.27.160, 14.22.27.160, /27. The valid go from 27.161 to 27.190. Look at them here. 27.161 to 27.190. And the broadcast is 27.181. So you see, I didn't have to compute all of them, and I could find all of them, no? Do you have any question? Okay, so I need you to be very fast with that, okay? Because this is something that we will be using a lot in the course. Because there is no way to work on networking if you don't know how to do subnetwork. So there are a lot of exercises there. Please do them. Okay? We'll continue with some exercises next class in 2 days. Okay, I see you.